कितने participants हैं? So once again, good afternoon, everyone, and welcome to day 3, session 3. So we will be covering today sequence modeling. Before that, I would like you to have the recap of yesterday's session. So we have seen the word embeddings yesterday. There is a new term that is an n-gram. So what is this n-gram and how do we connect our word embedding with this, right? This has come from yesterday's session. Then once it is done, then I'll take the today's session. So first of all, what is n-gram? N-gram is a sequence of n consecutive words or characters. In general, these are words, but sometimes specifically it is mentioned characters, then it is number of characters. So basically n is nothing but the number of units. Either it is a words or characters. Let's take an example. I love natural language processing. This is a sentence or text given to you. So what we mean by unigram? Unigram is 1, bigram is 2, and tri means 3, and we can have many other things. In general, we say it's n-gram. N is nothing but 1, 2, 3, 4, 5. More than 3 is difficult to handle. So generally, we can confine to trigrams only. So in this sentence, unigrams are I love natural language processing. How many unigrams are there? 5. In bigrams is a combination of first two, then second and third, then third and fourth, next two, next two, next two, including the previous one. So in case of bigram, it is I love natural language processing. Why do we do it? I'll come to that. So diagrams will be I love natural, and then the third, we start from the second one, love natural language. Then we start from the third one, natural language processing, right? And this is end of the sentence, so we will stop it here. So this is the example of unigram, bigram, trigram. Similarly, we can go for 4 grams, 5 grams, and so on. Now the question is why it is needed, why we are studying it, why, what is the need of that? So as in natural language processing, natural language, it is a text and text is sequential. Like forecasting is sequential. Time stamping, time series is sequential. एक के बाद एक आता है. So text is sequential. And here, as we have understood, as we have taken this, that the word order matters a lot. And the local context is also very much important. What has been said before this sentence, before this word, it matters a lot. So it is used in text representation and language modeling. That's why n-gram is important. So if a sentence has k words, how do we find the number of unigrams, bigrams, trigrams, and so on? So if we have the sentence, it has got k words, k may be 1, 2, 3, 4, 5. Then how many bigrams, n-grams will be there? N is 1, 2, 3. So 5 words in a sentence. Let's take an example of a sentence. It has got 5 words. So unigram is k is nothing but 5. So this formula k minus n plus 1. N is your unigram bigram. So in case of unigram, n is 1. So it would be k will be replaced by 5, n will be replaced by 1. So 5 minus 1 plus 1, it is 5. So again, go back. It's a 1. I love natural language processing. What is a k? K is 5. How many unigrams will be here? 5. I love natural language processing. What will be? How many will be the bigrams? 5 minus 2. 2 is coming from a unique bigram. 5 minus 2. And now we have to add 1. That is 4. Similarly, trigram is k is 5 and trigram 3 is coming from trigram and plus 1. That is 3. This is how we can calculate the number of grams. So if we have by default it is a word n-gram, but sometimes it is a character n-gram. It has to be explicitly defined, say. So word n-grams is based on the words, while character n-grams are based on the characters. So example sentence like she is dancing. Word unigrams is she is dancing. How many unigrams? 3. How many bigrams? She is she, is dancing. So 2 bigrams. And trigrams will be 1 only. So character bigrams will be NL if the word is NLP. Then character unigrams will be NLP 3. Character bigrams will be 2 NLLP. And let's take one more example like playing. Play has got how many characters? 7. So how many unigrams? 7. Character bigrams PL, LA, AY, YI, IN, NG. And character trigrams will be PLA, LAY, AYI, YIN, and ING. Now the question must be coming to your mind, why do we use it? Where do we use it? Right? So I'll come to the examples. Before that, why text representation is needed in terms of bigrams or in general. So as we have understood in the last class, the machines do not understand the text. So we need to convert our text into the numbers. So first of all, convert text into numerical vectors. There we have learned many ways. TF-IDF, we have seen word to vec, we have seen globe, we have seen skipgram, we have seen contextual embedding, right? Some are sparse, some are easy to understand, some are easy to compute, some are different. They are not considering the context and they are not considering the order. Then to overcome these challenges, we reach to the contextual later. So required before ML and DL models, this is needed. So text classification example, let's say I love NLP and second is I hate NLP, right? How can a machine differentiate them? Depending on the word embedding, right? So there must be some embedding for love and there must be some embedding for the hate, right? So n-gram in the text representation we have seen bag of words, TF, TF, IDF, wordgram, word to vec, so on. So first we start with the text, then it is converted into the tokens, removing the punctuations, white space and other things. Then we reach to the distinct vocabulary using the stemming and lemmatization, so many things to be done. Then ultimately we have the distinct vocabulary and every vocabulary is nothing but a word that is to be converted into the vector. This process is called as vectorization. So new term for you, what we have seen yesterday was nothing but the vectorization. Now we are coming back to the n-gram. So as we have seen, it is used to predict the next word. So if there's a sentence coming again and again, I love NLP, I love NLP, I love NLP, many a times in the corpus. It means we can count how many times, how many sentences are there in the corpus, and this sentence, how many times the same sentence, I love NLP, is coming. That is nothing but the probability of coming this sentence in the corpus. Right? What is the probability? How many times this is coming out of the all. So like if I say I love and question mark, it means what is the next word? Next word may be NLP, maybe coding, maybe Python. So it depends. It depends how frequent the next word, that is a prospect word, came in the corpus. For example, if I say there are two possibilities, either NLP or coding. So NLP came 90% times after I love, and coding came 10% times after I love. So what will be chosen? NLP. That is nothing but the statistics. So everything in the machine learning and of course NLP, there's an important role of statistics, that is probability. So now there comes the role of the bigram and trigram or unigram or n-gram. So probability of P word when previous word has already done. It means what is the probability of a word when the event, that is a previous word, that is known as a conditional probability. What is the probability of being one event when the previous event has happened? Example, probability of language. The word language is coming when natural has come already. So natural language, first is natural, second is language. What is the probability of language coming, the word language, when word natural has just come, right? It depends on the previous words. So in the case of unigram, because unigram, it is a one word. So first word, it means this, that is a start word. What is the probability of being this as a start word just after the dot, if it is a new sentence? Or what is the probability of the next word coming upward when this previous word has happened, has occurred many times? That depends on the probability. So in the case of trigram language model, the probability of coming any word when previous two words already in the same sequence. For example, we are checking the probability of coming processing. So what is the probability of, because they have happened already, natural language. So processing, probability of processing when natural and language, they both occurred in this sequence. Sequence matters a lot. We can't say the same as processing when language natural is different. Processing when natural language is different. So we have to maintain the order. So advantage of n-gram is simple, easy to compute, captures partial context, and works well in small data set. So actually the big question mark is about the data set. When we have a small data set, it doesn't work well in many of the cases. So we have to find such cases that yes, it is also working. It works good in small data set. Right. So that is a challenge that we have to check, that what are the best practices for the small data set. So now again, everything is not perfect. We have some challenges. Challenges are data sparsity, large vocabulary. It means if we have the large vocabulary, that is nothing but the dimensionality. And sparsity, it means we have the large vocabulary, but many of the places that has got the zeros, sparse matrix kind of thing. It cannot capture long range context. It has a limitation of taking, suppose I say, what is the probability of being this word when, how many words we can consider? So if I say, what is the probability of word n, wn, when w1, w2, w3, w4, up to 10, up to 20, up to 30, what can be the size of n? So that is again a challenge. We can't go beyond certain limit. And memory intensive. Of course, when we go beyond the range or we consider many things at time, then memory is always a constraint. But the question is utility. Yes, we have everywhere. We find the use of n-grams. Autocomplete, you must be using this one without writing anything. It completes your sentence. It completes the word. It corrects your spelling, right? The question must be coming to mind. How does it happen? The correction of spelling. because again it depends on the sequence you are typing. Sequence, it is already there in the corpus. How many times this kind of spelling is coming after these two words, after these three words, after this one word, right? So it corrects. Well, sometimes you find that you wanted to write something different that is out of vocabulary, but it is correcting again, right? That is coming from the statistics or probability. Machine translation is again language to language translation. Speech recognition from one language, from speech in which language it has been uh, said or written, then the language can be recognized. Sentiment analysis about the text, it is a positive, negative, and or neutral. It can be. The applications of engrams are applicable or used in the sentiment analysis also. Similarly, somehow we use it for the recommender system. So how engram models are used in spelling checking? So we'll take in detail. Engram models provide a statistical method for spell checking by calculating the probability of a sequence of words or character. By default, it is character in terms of the spelling, and words in terms of completing the sentence. So the process generally involves the steps like error detection. If you're writing a word that has a spelling mistake or misspelling, then the model flags a word as a potential misspelling if the engram sequence it is a part has a very low or zero probability. What you are typing is not found in the corpus. It means it has a zero probability or very less probability appearing in the training corpus. So it means it is a misspelling. So it is first it is detected that yes, there is an error. Second, candidate generation. What are the possibility if it is not correct, what should be there? So all the candidates are generated. Then third is core role of engram here is to rank the candidates correction. Ranking is done on the basis of the probability. For example, the same example I took yesterday, the cat sat on the, for example, instead of mat, I have written MEET, meat. The cat sat on the meat. It's a spelling mistake. So it is misspelling. So instead of that, during the training corpus, it has been checked how many times the cat sat on the mat, sofa, couch, carpet, table. These are the candidate. Uh, these are the candidates, right? And now the probability of these one will be checked, and highest probability will be set. That is MAT, MAT. Instead of MEET, it will be corrected by MET. So each candidate work is placed back into the original sentence context, and the engram model calculates the probability of new sequence. The candidates that result in the highest probability, the most neutral sounding and contextually appropriate. Of course, we have to consider, we have to keep intact our context, in which context it has been said. We cannot say that all of a sudden new context will be there. The context is very important. We cannot deviate from the context. Considering the context, what are the possible candidates? So instead of MET, MET, that is a misspelling. It may be MAT or it may be something else. Those are relevant to that context. So unlike simple dictionary lookups, what we do in dictionary, we just check it. Here, the context awareness is needed. In the dictionary, there's nothing to do like context, because context come from the previous words or sentences. So that is the beauty of NLP or engram, that how it is different from the dictionary. Dictionary doesn't have the context, while it has the context. So the same example again, I love NLP, and the spelling of love is LUV instead of LOVE. Then it takes the context from both the words I and NLP, where it is corrected to LOVE. because LUV is not a dictionary word. Being a human being, you understand that it is nothing like LUV, but it is same as LOVE. No, it is not a literal word, but it is equivalent to that. That is what we understand it. Somehow, if it is LOVE, LOOVE, somehow instead of LOVE, it is LOOVE, then also we understand this is about the love, right? So machine will correct it. So here the context is considered that is about the NLP, and people like working in it. People like or love this course. That's why it has been written. And the context, without changing the context, it corrects the spelling. Right? I hope you are getting it. The second benefit is, or a key thing about this engram is statistical and data driven. It is based on the corpora or corpus. So it's not coming spontaneously from anywhere. It depends on the corpus you are targeting. If your corpus is having something different things, those are out of the scene, then also it will come from the corpus. So it is not generated, in fact, it's coming from the text. That is what I want to say. So it is language independent, adaptable to various domains, provided sufficient training data is, that is a constraint. If we don't have the sufficient training data, then it may not work well. And efficiency, while more advanced deep learning models exist today, Ngram models remain fundamental. Still, we are working on that. We are using that and can offer a balance of speed and accuracy. So second problem was the data sparsity. What we mean by that, as we increase our n by unigram, n is 1, 2, 3, 4, 5. If we increase n, then the vocabulary combinations increase exponentially. So if we have small n, the less context it takes in terms of word, how many words are behind it. So that is a less context. If we have a large n, big N, then it has a more context but sparse. So common choices unigram, bigram, and at the most trigram. Before after that, it becomes complicated. So in classification, I'm saying if I'm not happy, I'm taking the example of bigram. So you'll see the difference. In case of unigram, it will say may classify this as a positive because happy is positive word. I am happy. Happy is a positive word, right? But when I take bigram, it would be I am not happy. So instead of happy, it would be not happy. And not happy is not a positive word. It is a negative word. So here see the difference. Taking only unigram, so we have to choose it wisely, which gram it is best suited, right? So not happy because of bigram, instead of positive sentence, it has become the negative sentence. So in another example, in spam detection, like free money, if I take unigram, it would be free something and money something. And when I take bigram, it is free money. So if the rule says anything free is not good, and free money, it means it's a spam. Similarly, win is, if I take unigram in win price, win is good one, price is also good one. But win price may be the suspicious thing and it leads to the spam. I hope you're getting. So now I'm connecting my yesterday's lecture with this one. We understood word embeddings, right? So now the question is, are we not happy with word embeddings? Why do we use n-grams, and how n-grams are related with the word embeddings? How do we connect it? So in the case of n-gram, context is limited because we cannot go beyond certain threshold, while in word embedding, it considers the context to a large extent. Dimensionality in terms of n-gram is high because it considers the sparsity. Word embeddings also high, but it is dense. It means less number of zeros, no zeros in fact. In the vector, everything is precisely filled with non-zeros. Semantic meaning in terms of n-gram, it doesn't consider, while word embeddings, yes, it is. So it depends on the use case. Either we should use word embedding or n-grams. It's not necessary that we always use word embeddings. If it's not needed, then we should go for that because the n-grams are easy to handle, less complicated. So when we have less number of small data set, of course, n-gram is better. While we have large data sets, then word embeddings are good. N-grams are used in traditional ML models, while word embeddings are used in deep learning models. N-grams are used in manual feature engineering, while word embeddings are used in automatic feature learning. N-grams use sparse metrics, many of them are zero, while these are non-zeros. N-grams has limited context, while word embeddings have, they capture semantic similarity. So in case when we don't need semantic similarity, just we have to count the frequency or something else, then instead of going for the word embeddings, they have their own overhead, of course. And to handle them, it needs expertise or infrastructure. So it's time for the question. If you have understood, please look at the question and try to answer with me. The question is, in an n-gram language model, the probability of a word depends on what? All words in the document? Not possible. Addendum words? Nothing. Previous n minus 1 word? Yes. Only the next word? No. So you are right. Answer is C. No doubt about it. Very clear and simple question. So I'm taking this question for kind of your preparation for the quiz. Many of the questions will be similar. Many of the questions will be similar. Not same, will be similar. Next question. If a sentence contains 10 words, how many bigrams are possible? Again, the formula is k minus n plus 1. What is k? K is 10 and bigram is 2. So it would be 10 minus 2 plus 1. That is A. Yes, right. So this is answer. A is 9. That is k minus n plus 1 is equal to 10 minus 2 plus 1. That is 9. I hope it's clear. Now, next question. In the sentence, natural language processing is interesting. This is a sentence. Within the quotes, it is a sentence. So, which is the third trigram? So, first trigram is innate. When we don't specify word or character, it is by default word, right? So, first trigram is natural language processing. Second is language processing is. The third is processing is interesting. You're right. The answer is B. I hope there's no doubt about it. Next question. What happens when n increases in n-gram model? So context decreases, models become simpler, not possible. Accuracy always decreases. No, because if it is, then why should we go for the higher complexity? Context increases, but sparsity increases. Answer is D. You have written well. Next question. Consider sentence. NLP is fascinating field. Yes, it's true, but we have to check the trigrams. How many trigrams can be formed? How many words are there? Just check how many words are there. 5. So formula is k minus n plus 1. This is 5 minus 3 plus 1. So answer is 3. Next question. Which factor mainly affects the performance of n-gram model? Is it first? A answer? No. CPU speeds only? No. Size of training corpus? Question mark. Font size? No. So only possible solution is size of training corpus. C. Correct. So now we'll come to the today's session, that is sequence modeling basics. So I hope you had a recap. You are having the cohesiveness in the lectures. First, what we have done, second day, what we have done. Now, first was connected with the second day's session, and second day's session is connected with the third. Now, what is the sequence modeling basics? As we have seen in the beginning of this session, sequence text is a sequential, one by one coming. The word coming next is depends on the previous one. That is a kind of sequence. Time series forecasting, weather forecasting, it depends on the previous factors, what has happened. So that is what we have to learn, that how they are having the dependency on the next to come, next to predict. So this is what we are going to cover, sequence modeling. Basically, there are two sequence modeling techniques. First is part of speech and second is NER. We'll take both one by one. So sequence model process of predicting or labeling each element of an ordered sequence based on the context, that we have understood very well, right? It depends on the previous words, right? So input is kind of a sequence, x1, x2, xn, that is x, and what will be the next? If we know the output, a corresponding label sequences y1, y2, yn, that is output, and they are discrete in nature and they are not overlapping. So labels are interdependent. Labels means they are interdependent. The best label for xi often depends on neighbors. So xi depends on xi minus 1 or sometime xi plus 1, right? So far here we'll see xi depends on xi minus 1 or xi minus 2 or xi minus 3, till what we can go in previous data. So contrast with independent classification, each data point is labeled in isolation. Isolation means they are not dependent on each other. In the naive Bayes classifier, we assume that x1, x2, x3, they are independent of each other. Real life is not possible, but somehow the naive Bayes classifier is so unique, so simple, and it works for many of the application. So, and it is based on the probability. But in real life, we don't find such cases. For example, if I say win prize, lottery, then they are the words leading to spam, right? But the naive Bayes classifier, they say win, prize, lottery, they are independent of each other, right? So for some cases, it's not possible. So let's take an example where the ambiguity comes in. That is a challenge with the NLP. The challenges with the NLP are the ambiguities. So we'll try to understand by different kind of ambiguities by the examples. First is she hit the boy with a stick. Now there are two possibilities, that she used the stick Did she use the stick for hitting? She hit the boy with the stick. Boy was having the stick or she was having the stick? There are two questions in mind. So that leads to the ambiguity. Second, old men and women were sitting together or there. So old men and women of any age, because women specifically are not specified with the old adjective, or old men and old women. If I say old men and women, it seems like women and men both are old, all are old, while some may say only the men are old, but women may not be old, not specifically decided or mentioned. That is again considered as ambiguity. Second, we have taken the example in the previous classes, flying planes. So planes को fly करना is dangerous, or the planes those are flying flying is nothing but an adjective, those are dangerous. So flying is with plane, or flying is an adjective verb. Flying is a part of speech. What is the part of speech of flying? Is it a verb or adjective? That is what we have to understand. The next, he fed her dog biscuits. So he fed her dogs biscuit. Question is, did he feed her dog biscuits or did he feed her dog some biscuits? Again, there's a ambiguity. So similarly, we can have several kinds of ambiguity. Several examples are there. So to resolve this, we want machine to work like the intelligent person as we are doing. We understand because what has been said, what is in practice, how does it happen? Just give me a second, please. सही हुआ कि नहीं? So actually, such kind of ambiguities may lead to the inaccurate or incorrect results. So we have to be specific in which context it has been used. It depends on the context only. And context comes from the previous things, previous sentences. So in terms of sequences, it is hard to understand the context. Let's take one more example. I saw the men with the telescope. Did I use the telescope? I saw means me. Did I use or did the man had it? किसके पास था telescope? With me or with man? That is again. So I saw a man with the telescope on the hill. So who was on the hill at the same time? I was or the man? So variable length inputs sentences ranging from 1 to 500 plus tokens is possible. So many ambiguities. If this is a small sentence, I saw the man with the telescope has got two ambiguities, two possibilities. I saw the man with the telescope on the hill. There's now 4 possibilities. And if keep on adding, I can have 5, 1, 2 ambiguities in the same sentence if we have the number of tokens more than 500. So long range dependencies, a verb may agree with the subject 20 words earlier. So ambiguities, the harder bank can be, running can be, the word can be noun or verb, the word bank can be noun or verb. Banking is a good deal, right? Banking is a good habit, or bank, it is a noun. Running can be gerund or adjective. He's a running athlete. He's a running person. We are putting running as an adjective. While running, I was running. It is coming from run. When we put a ing after a verb, it becomes gerund. So context shift is meaning of a word changes depending on the surrounding words. That is that creates the ambiguity. Structural constraints, grammar rules must be respected across the whole sequence. So if as we have done a story yesterday, Sachin Tendulkar is a good player. He has a brother, he is 5 years younger to him, and he is also playing, right? So I'm saying he is also playing, it means we are talking about the brother. And if I say he is in a bank, so we are talking about Sachin or his brother. So if we keep on writing the sentences after many a sentence, I felt who is he? So we may lose the context. So it's not only that we are considering only one sentence, two sentences, three sentences. It may be more than that. This is pipeline, NLP pipeline overview. First, we start from raw text, and it is to be pre-processed, tokenization. Then the part of speech comes into the picture. Is it a noun? It is a verb? It is gerund? It is something else? So many part of speech tags are possible. We'll have a look at it. Then we do parsing and named entity recognition, and then ultimately we reach to the conclusion, either it is a classification problem or any other problem. So we'll reach to the task, right? So part of speech and NER are the sequence labeling task. Here, that is what we are learning today's session. So before we come to the next thing, we have some questions, what we have done so far in sequence modeling. So please have a look at this. Sequence modeling is mainly used for is it for image classification? No. Big no. Predicting structured output sequence? Database management? No. Data compression? No. So answer is clear that it is predicting structured output sequence. Second is, in sequence modeling, word order is, does it matter? Ignored, random, important, and optional. Answer is C. Yes, you're right. It's C. In sequence labeling, the output is one label per document, one label per word or token, one label per paragraph, one label per dataset. What do you say? It is part of speech. We can have per word, one label per word. It depends, right? One label per word. So if we talk about part of speech, yes, it is one word per token. If we talk about NER, yes, it is one word, one label per word. Which the following is an example of sequence modeling? Sentiment classification, spam detection, part of speech tagging, image resizing. Sequence modeling has got two things, either part of speech or NER. It's nothing to do with the spam detection. Spam detection is based on the tokens inside the text for which we are detecting, right? So it is kind of a classification problem. First is also classification. Part of speech is a sequence modeling, and image resizing is nothing to do with this, right? So answer is C. Answer is C. You're right, Prasad. Now come to the this one. So if we have, how do we do tokenization? Although we have done it, I quickly summarize it again. So input is this: New York-based companies do not stop. This is different kind of example we have done a day before yesterday. So here, look at this. New is something, a new word, while York-based is a single word. Look at this hyphen. Hyphen made it one word. Companies, one word. Don't stop. Do and note. These are the different tokens. So first, tokenization is done. Split on white spaces, punctuation, fast. If we tokenize on them, they are naive. Subword tokenization, running. Running is taken as a single word if it is, but again we can make a subword. Running came from word, original word is a run, and we suffixed it with ning, right? Somehow if I write instead of this double ning instead of run and then double ing, that it may be out of vocabulary. What do you mean by out of vocabulary? Those are not in the dictionary. Those are the new words. Earlier, some words are not there in the dictionary. Later, they were in the practice, so included in the dictionary. Let's take an example of Xeroxing. Xeroxing is a synonym to getting a printout, right? Helicoptering. Helicoptering it is not a word. Helicopter is a word. Helicoptering is a new word considered as kind of a watching from above, like googling. Googling is not a word, but nowadays people understand it. You just google. She was googling it. It means just searching. If I say googling is kind of a searching synonym to that. There are lots of words. Earlier they were not there, but they become so popular that they are the part of the vocabulary or a dictionary. Correct tokenization is critical. Errors propagate to part of speech and NER stages. If we have something new that is not somehow written, is it a part? What is the part of speech of that, or what is this word? For example, I say Savai Mansingh is the name of the person, name of the city, name of the street, name of the hospital, name of this, name of that. On the name of this person, so many things are named. So in the sentence, what is this? That is to be understood. So these are they are the corpus available. Links are available. I will share it with you. Kindly have a look at it whenever you have time. So there are some linguistic words in terms in the era of natural language processing. The structure of word is known as a morphology, stem, prefix, suffix. So basic words, root words, llamas, those means lexes. These are part of natural language processing. Structure of words is morphology. Abstract unit we cannot decompose further. That is, run is a llama, and run, rain, running is lexeme. Token, an instance of a word in the text. Instance of the word in the text. So run, rain, running, all are the tokens. Syntax, how words combine into phrases or sentences. What is the syntax in English? It's a subject, verb and object. This is how we go. हिंदी में कुछ और चलता है, संज्ञा, सर्वनाम, कर्ता, जो भी है, क्या order we have to follow. और इंग्लिश में कुछ किसी और लैंग्वेज में कुछ और चलता है. That is nothing but a protocol, grammar. What is lemma? Lemma is running ka is a base form is run. Rain, RN ka base form is run. M का MR is was were been being इन सब का base है BE. And if we have good, better, best, what is the lemma? Is good. Type, what kind of type it has? Unique vocabulary item hai, or it increases the size. We keep on increasing the vocabulary items. It means size is increased. So have a look at this question. An annotated corpus contains annotated. It means someone has looked at it and corrected it, annotated it. So if I ask someone what is this, he says it's a mobile. It means this is annotation. And if I ask someone, second person, he says is a phone. Someone says it's a mobile, someone says it's a phone. And I ask third one for majority voting, says a mobile. It means we'll say the tag associated with this instrument is mobile. So an annotated corpus contains only raw text, annotated. Human assigned labels, images, audio files. Answer is B, human assigned labels. So initially what happened when there were no machines? Machines need training data. So before in hand we need training data that is done by the annotators, human beings, experts in the domain. Right? If we ask that, what is this? If we go to the doctor and say, this is what we found in an image in a brain. What is this? He'll say, it is kind of a tumor. It is a tumor, right? So kind of an annotation done by the expert. So Pantry Bank is very popular, state of the art. There are many tree banks. This is one of the good, is one of the best. Is mainly used for image segmentation, part of speech tagging, speech synthesis, translation only. Answer is B. So this is done by the human annotators. So we'll come to this part of speech tagging. How does it happen? Can we do it? Can we contribute in this? Yes, we can. This is freeware and GitHub pe hai possible. So look at this example. We have the sentence, the quick brown for jumps over the lazy dog. In short, we have DT. DT is a determiner. Determiner is A and D. Whenever we find A, N and D, these are the determiners. तो हम इसको बोलेंगे DT. And JJ is adjective. Brown is also adjective. Fox is noun. Jumps is verb. Verb का plural है. Over is in. The is article. Lazy is adjective. And dog is again NN. That is what? One label per token. हर label का एक अपना token है. So part of speech tagging assigns a grammatical category, noun, verb, adjective, to each token. So one of the oldest NLP tasks is a rule-based tagger. Rule-based means there are some if and buts. If this happens, if any of the noun comes, we understand what we mean by noun. So all the nouns are together. We kept in a corpus and say if anyone from this box, then it is a noun. If anything from this one, it is a verb. If anything from this, these are nothing but the rules. So this happened in 1960s. That is known as a rule-based taggers. So what is the drawback about this? If something is not known to anything, it may not be tagged. And if someone is making a mistake by chance, then it is accepted until unless it is annotated by many. बहुत सारे लोगों को आपने बोला आप भी देखो, आप भी देखो, आप भी देखो, and then majority of voting is taken. So provides syntactic structure without full parsing. Ambiguity, book can be NN. Now the annotators say we don't understand book. Is it a noun or a book a ticket, book a flight? So which book you are talking about? Write a book, read a book is a noun, while book a flight is a verb. So must be resolved by the context, right? So book a flight, it means it is a verb. We can understand it. While read a book, give me a book, then it is a noun. So state of the art accuracy is more than 90% in pantry bank using neural models. Tag depends on tag sets, like pantry bank 45 tags are available. Universal part of speech, that is again a data set, 17 tags are there. Clause is also name of the tree bank, that is 150 plus tags. So according to their need, everything has been tagged under this. So this is pantry bank. I consider this is a state of the art. So taking the example of that. So NN is a noun. If we don't have S here after this NN, that is, it means a singular. So dog, city, arm, water. These are nothing but the noun. S means plural. Noun है but plural है साथ में. So look at this dog. Now it has become dogs, city, cities, arm, arms, water, waters. But meaning shift in NNS when earlier it was arm. Arm is a body part. Arm is a body part. It was something different in the NN. While when we make it arms, it means kind of a weapons. Water. NNS, in the case of NNS, it becomes waters. It's kind of a wave or a collection of yes, waves. So next is NNP. NNP is a proper noun. We have got different kind of nouns. One is proper noun, name of the person, name of the place. Proper noun and singular, that is London, Barack Obama wala proper noun. Then we have the proper noun with singular. We can have that in very rare cases. Verb, VB is a verb base form, that is run, base se aaya hai, run, eat, play, sing. These are the base forms. Verb with past tense is run became rain, eat became ate, play became played, sing became sing a song became sang. Then verb G for gerund, verb भी है but ing use हुआ है साथ में. So run is running, eat is eating, play is playing, sing is singing. Verb but past particle. It means eat become eaten, run became run, play became played. Adjective, all adjectives are JJ. In terms of pantry bank, they have something different nomenclature in different banks. We are talking about PTB. So in PTB, adjectives are JJ. So quick, tall, long, short, fat, fast, beautiful, all these are adjectives. Adverbs are quickly, very fast. These are adverbs. Determiner are the, and. In is preposition. In is used for preposition in PTB. It is in, on, that, while CC is coordinating conjunctions and fillers and, but, or. PRP is personal pronoun. I, he, she, they, we. These are the personal pronoun. I hope it's clear. So we in the second data set, that is UPOS, instead of these 15 tag sets, we have 17. right? So in the next one, then the question is where the problem comes in, what are the ambiguities? So look at this book. I read the book. It is a context one. So we can easily say book is noun. But in the different example, please book a flight. So here the book is considered as a verb base form. The sentence turn on the light. So what is light here? It is noun. Similarly, using the light, we have a different sentence, carry the light bag. So it is adjective. We are talking about the bag. Bag is very light. It is a carry the light bag. So here light becomes the adjective. Carry the heavy bag. It means heavy is the adjective. So we are differentiating light in both the cases, NN versus 3J. Round, a round table. We are specifying a table which is round. That is an adjective. She will round the band. Then here, round is nothing but the verb. A fast car. It is again, car is very fast. It is an adjective. He runs fast. Here it is RB. What was RB? Adverb. This is adverb. Quickly, very RB is adverb. A birthday present. That is, we are talking about present. What is this present? Present is noun. Present is noun, is gift. A present students stand. That is adjective. Those who are present, please stand. That is adjective. Now, time for the question. So, part of speech tagging assigns meaningful labels, grammar categories, sentiment scores, or entity type. So far, we have seen part of speech tagging. What do we mean by that? Meaning labels, nothing to do with the meaning. Grammar is nothing to do with the grammar. Sentiment, no. And it's a type of entity. Entity है ना ये तो. Grammar categories. A word running in she's running is tagged as VBG, verb, gerund. It is a verb, but ing जब भी हम लगाते हैं, it becomes the gerund. Sometimes we also say gerund. Algorithms for part of speech tagging. Yes, you're right, Madhuri. Algorithms for part of speech tagging. Early system, as I mentioned in previous slides, it started rule-based. It started in 1960s till 1980s. It happened. Handcrafted rules. If this is the condition, then this is the Y rule. 2 steps like dictionary lookup. What are the possible tags in there? And then if there's a ambiguity, then that is to be disambiguated. If there's an error, please remove the error. There are 2 steps. Then Brill tagger came in 1992. Learned transformation rules automatically from data. It means some programs were written, were given, and programs are nothing but the rules, but they were not handcrafted. They were generic, and using those rules, the tagging happened. Rule example, if a word ends in ing and it is preceded by a noun, then it is gerund, verb gerund. Advantage, transparent, easy to debug, no training data needed. Right? It is known as a lazy learner. As soon as the data comes in, immediately tag it. That is lazy learner. We don't need a training data. And when the test case comes in, just tag it. Disadvantage is brittle. It means fails on out of vocabulary. There may be many words, those are still not part of the vocabulary or the dictionary. Then how do we handle it? That time it fails. Immediately we have to build. That may be expensive because we don't understand the meaning of that. That is to be digged upon. Modern use, still used for post processing, rule injection on top of the ML model. So there's a model that is known as a hidden Markov model for part of speech tagging. Hidden Markov model. It means we have some states, we have some observation. Looking at the observations, these are the words. States may be derived using the probability. So how many times this word is coming as this part of speech or maybe different part of speech in this context, then that is nothing but a hidden state. That is to be revealed actually. So key assumption in the Markov properties, tag depends only on the previous tag, just only one previous tag. Output independencies, word depends only its tag. Word depends only its tag. So two probabilities table, we have transition table, transition. It means what is the probability of Ti when Ti minus 1 has happened. And emission is what is the probability of Wi, that is observation, when this part of speech happened. T is your state and observation is W. So here we have one state and previous state. Here we have one word or observation when this is the chance. So decoding, find the most likely tag sequence given observations is possible with the Viterbi algorithm. And the complexity of Viterbi algorithms n into t square, n into t into t. So it is based on the count, maximum likelihood estimation on annotated corpus. So it depends on the corpus we are using. Maximum likelihood, what are the chances that it is going to happen? Highest probability kiski hai? So if it doesn't work, sometimes it doesn't work. Somehow in the formula, if it is the case is never seen, it means the probability so far is 0. Then how do we handle it? That is through the smoothing. So there are two type of smoothing in use, that is add k, add something in denominator and numerator of the formula. And second is Nasser-Ni to handle unseen and transitions emission. What is this unseen? So something never happened in this type of part of speech tag or a class, then how do we handle it? Because it will make everything 0. So what happens in the case of Viterbi algorithm? That is a decoding HMM, hidden Markov model. So goal is to find the Y, and we have argument max is nothing but out of these, out of many, which one is the highest one? Argument max. So out of, there are many Y's. So what is the probability of Y when X has happened? What is the probability of Y1 when X has happened? What is the probability of Y2? What is the probability of all the Y's like Yn, right? So when we say probability, joint probability, what is this joint probability? Probability of X, Y. साथ साथ होने की probability, इन दोनों के साथ साथ होने की probability, right? When this is book, what is the probability? It is noun. When it is a book, what is the probability? It is verb, right? So, and again, there are many possible cases. So which has the highest probability? That is argmax. So dynamic probability, dynamic programming over a trellis like tags and positions. Recurrence is VTI. V is about Viterbi. T and J is a formula given that, and we have to use the record which previous tags gives the maximum. We have to trace back and choose the best. These are the possible things. Choose the best. Best means highest, because we are reaching ultimately the argument max. So here the dynamic programming is used. We can have this kind of thing. So for example, something is written here, something is written here. We calculate this thing, and we need to calculate. We also calculated this. We also calculated it. This one is based on these three, maximum of these one. So this, for example, this is maximum. So we'll take it from here. Again, look at this data, and this is to be calculated, right? This is to be calculated, and this depends on maximum of this, right? So maximum in the case of dynamic programming, and ultimately we can say this came from this came from this came from this. This is a sequence we are getting. So that's why dynamic programming is retaining the previous states in memory so that we can backtrack and get the previous states. So there's one more model, that is the maximum entropy Markov model, that is known as a MEMM. It is a discriminative model. There are two type of model. That is, one is discriminative, that is classifier, and second is predictive, that is clustering. So we have a model like what is the probability of y when x has happened instead of probability of x and y together. It happens in the discrimination. So logistic regression we'll see in classification also. To predict each tag given rich features using the plus the previous tag. In the previously, what was the tag we are retaining, and using the new features, how do we reach to the new tag? The feature engineering is a term which says what is the word identity, prefix or suffix is added or not added. Capitalization in English, if something is, I've taken the example of will, if you remember. Capital WILL is a noun because it's the name of the person, while small WILL, say this is will, and this is will. This is a small one, no? This is small one. So different things, it matters a lot. Previous tags, what has been said, because it depends on the grammar. If I say grammar is like subject, verb and object, and subject is already there and we are at the second place, so it cannot be again noun. It depends on the previous tag. And part of speech content, it may be the adjective, it may be the supporting verb, helping verb, or maybe anything else. It depends what has happened before that. So using this model, MEMM over HMMs can include arbitrary overlapping features without independence assumption. So here we are considering the previous tag also. But again, it's a challenge, label bias problem, because we depend on the previous one. So biasing is possible. So here the example of MEMM, that is we have observations. Observation is nothing but the word in the text, and states are the part of speech. So probability of being these two words, observation, this is observation, and the second observation when it is this one, when this is this one, and we keep on looking at these. These are nothing but the probability. They lie between 0 to 1, and we choose the highest one out of these two possible things. Then this observation with this state 2, and this is next observation is being next observation is probability is 0.4. So we may not do it in one lecture, all these things, because they are the bit complicated and takes time. So we can take it three models. One is conditional random field. I'll explain this CRF with the help of these previous two. So difference is only enough for today's lecture. First is HMM, hidden Markov model. Second is MEMM, and third is CRF, that is linear chain CRF. CRF, then again we have a discrimination with linear chain. So model uses generative. It is HMM is generative. It is a joint probability, while MEMM is only conditional probability. Locally का मतलब it considers only the same sentence, while CRF linear chain, it is again discriminative, but it is based on whole the corpus or whole the document if we go sentence by sentence. So what is the issue with the HMM? There are limited features we can use because it is based on the joint probability. MEMM, it is locally although, but it has a rich features similarly for CRF. Label biasing in HMM because it works for the limited one, so no biasing. Sometimes in MEMM, yes, they may be low because it depends on the locally. So context may change after the local. That's why we say it's a biasing. While it doesn't happen in CRF because it considers the whole the corpus. Training in HMM is very limited. It counts. And here in MEMM, we use the gradient, and in CRF, it's kind of a neural network feed forward and backward. Decoding is Viterbi, while in MEMM, we have greedy or Viterbi. There are two kind of decoding is possible. Again, CRF considers Viterbi. When we talk about the accuracy in all three methods, with the help of Pantry Bank, with this data set only. So it is HMM says is approximately 95%, while MEMM says is approximately 96, and in CRF 97. So only a few texts are inaccurately predicted in the case of CRF. Now, time for the question. Please read it carefully. It will help you to understand the previous concepts. So HMM uses which algorithm to find the best text sequence? Nothing to do with the back propagation. HMM, it uses Viterbi only for the decoding. And K-means is for clustering, and gradient descent is not applicable for HMM. It is used for MEMM. So Viterbi is answer. Gradient descent is used, Prasad, in the MEMM. Let's go back. This here. This is gradient. Training is possible with the max and gradient, name of the function. I hope it's clear. Madhuri is not B. If you are talking about the K-means, it's not the K. K-means is kind of a clustering algorithm. We are doing the sequencing. Now, CRF model is independent labels only. Label dependencies, random words, image pixels. So you are very sure about image pixels is not the correct answer. Random words is not the correct answer. Label dependency. Why we are doing it? For marking the tags, that is labels. So these are not independent, they are label dependent. So how do we do it? Go back here. So we have, it is a discriminative model, CRF, and it is label bias. No, it is not label bias. Now, the second type of sequence modeling is NER. If you want, we can take a break of 5 minutes. Otherwise, I can continue. Please write in chat. Would you like to take break or should I continue? It's 3:30 by my watch. Bhavna is writing break, please. What others says? What others say is okay for them. Okay. So one more break is requested. Okay. It's a 5-minute break. Yes, Prasad. We are taking a break of 5 minutes. Please move around. Please move around and come back after 5 minutes. So we are back after break. Hope everyone is also back. Okay. So now we are coming to the NER. So far we have seen the sequence modeling, that is part of speech. The second one is NER. So let's take an example of Barack Obama visited New York on Monday to meet Google executives. We understood the sentence. Now we have to map each label with part of speech with NER. So Barack, as we know, so Barack Obama is a name of the person, right? So this is person, PER, Barack Obama. Now, this is New York. New York, although there are two words, but it is a location. Date is Monday. Google executives, it means it's about the organization Google. So three named entities here. First is person, second is location, third is date, and fourth is organization. Four named entities. Identify spans of text that offer to named entities and specify their type. First, we have to find is it entity, or if it is, then what is the type. The person, organization, location, date, time, money, person. These are the possible entities. We can have many more others. Keep on digging upon it. What is inside that? What is inside that? And how do we classify? So, shared task at MUC6 in 1995 first formalized the NER problem. So, applications are information extraction. For example, in question answering, we need what kind of information it is, information extraction. Who is the Prime Minister of India? Suppose this is a question. Then information is to be extracted instead of giving the whole para or whole document exactly where the answer lies, our cursor reaches to that place. That is information extraction. Knowledge graph construction, how the objects are connected, how the entities are connected with each other in terms of some relationship. That is a knowledge graph construction. Question answering, search. These are the use cases of NER. Suppose I know the answer, who is the Prime Minister of India? And the answer should be the name, right? So answer type is a person. Answer type is a person. That is a named entity. So we have to search the answer from the paragraph, from the document, from the corpus, such a way that it gives the person as a named entity. So harder than a part of speech, of course. Part of speech is kind of a moderate problem. It is harder than that. Multi-token spans, nested entities. We have entity within that entity. Domain specific type, genes in bio-NLP. Some domains are very specific and we need experts to know the entities. State of the art is greater than 93 F1 score on, this is the dataset, name of the dataset, Cornell, we say it, Cornell 2003, using transformer models. So this is person. Some examples, person. PER is a person, that is Barack Obama, Albert Einstein, Elon Musk, Narendra Modi, Rahul Gandhi, anything. ORG is representing organization, Google, United States, Apple, and many more. LOC is location, Mount Everest, Amazon River. GPE. This is a geopolitical entity. Geopolitical entity. France. It may be the location name, but somehow it is considered under GPE. New York City, Texas. In which geography they are situated? Date and period: Monday, January 2024, the 1990s. Time: 3 p.m., midnight, noon, forenoon. Money, monetary value: dollars, rupees, yorks. This is percentage: 85%, 3%. North, nationality: American, Indian, Buddhist, Republican. Event: named entities: World War II, the Olympiad, the final cup, cricket match. Product or creation: iPhone 15, Tesla, iPhone 17e, right? Law, named laws: GDPR, the First Amendment, and there are many others. So again, we can have the sub-entity or a bifurcation in the entities. For boundary detection, where does an entity start and end? Bank of America is one organization and not separate. Barack Obama. It means entity start from Barack and end at Obama. This or Bank of America is one organization, not the three words Bank of America, United States of America, right? It is कहाँ से शुरू होता है, कहाँ पे खत्म होता है. Type ambiguity: Washington. It is the name of the person. We are talking about the George Washington or state or GPE. It has a role in three. So that is ambiguity. Nested entities: University of California, Berkeley. We have comma and Berkeley. Contains California as a nested GPE. So University of California, and then we have another entity. So there are two entities that is known as a nested entity within an entity. So domain shift: a model trained on news performs poorly on social media, clinical text, or legal documents. So if we try to find the entity in some other area while it doesn't exist there, it is somewhere else. Low resource languages like Hindi: little annotated data for many of the words, 7,000 plus languages. Emerging entities: new person, organization name not seen in training. Like nowadays we have got names of the kids, newborn kids. It's like Kia, Gia, Ria, Diara. These are not available. So how do we say these are the name of the person? Noisy text, spelling errors, abbreviations, hashtags, and mentions. Then hashtag Elon Musk. It means that is to be removed or not to be removed, right? So that may create a problem. Hashtag. So now look at the question. Yes, quiz. It's a quiz time. You're right, Prasad. So Google in the sentence, she works at Google, is tagged as a Google. Google ko, how do you tag it? Is it a person? Is it a location? It is an organization or verb? Please answer. Prasad, if you are asking about the quiz, then it is going to happen on Monday at 5:30. Monday, 5:30, first quiz. So it is a organization. C, answer is correct. C is the correct answer. Now, which data set is widely used for NER? That just I explained you. That is C, yes, Cornell 2003. So similar kind of questions will be there in the quiz. That's why I'm doing the practice with you. So now the question is, everything we have done part of speech, we have done NER, we have done word embedding. Now the question is, how do we evaluate, how do we get data sets, and what are the applications? Evaluation is very important metric. what is the evaluation metric? How do we validate what we have done? So in the part of speech tagging, the evaluation metric is accuracy. Accuracy, it means fraction of tokens with correct tag out of all the tags asked for. Suppose I give you the 100 question, please tag them, and you do it 90% times is correct, and remaining 10% times not that correct, not correct. So it's 90 by 100 is a fraction of tokens with the correct tag. What we mean by gold standard is the name of the data set. Name of the data set. It means it's trustworthy, state of the art. NER. NER is a named entity aggregation. Span level we have precision, recall, and F1 score. These are the three metrics, and precision is defined as a true positive divided by true positive plus false positive. P, precision का P ले लीजिए, and TP, FP, TP. It means all are P's. So this is how do you remember it. Precision, it means what are positive, what are all the positives, TP plus FP. But by mistake, there are some FPs, so we missed it. So that is true positives divided by true positive, and if FP is 0, the precision is going to be 1, right? Recall. Recall has got TP divided by TP plus FN. So here P is missing, so it's the formula for the recall. So TP is a true positive, predicted, actually right, and we predicted it right. False negative, it means they are positive, but we say it's negative. Predicted negative, actually positive. And what is this F1? F1 is 2PR divided by P plus R. So sometimes true positive is good, sometimes recall is good. So F1 is a harmonic mean of these two. So we have to have a trade-off. We want both of them should be good. Although the precision lies between 0 to 1, and recall is also lies between 0 to 1. And it is kind of this. It is kind of this. So if this is the graph, and this is like this graph. If it is precision is growing, recall is this. This is recall. Y-axis is recall, precision is this. So it should be like this. Precision is growing, recall is growing. But real life, it doesn't happen because we are missing the true negatives, false negatives and false positives. And they are opposite to each other, right? In any case, if everything is very good, all are true positives or true negatives. True negatives is also good. So we don't have any false negative, we don't have any false positive, all are 0, then is precision recall go hand in hand. But in general, this is the graph that if this is going, precision is going, so if precision is going, yes, here. So it goes like this. While we want, if it is 0, this is 1, 1, 1, comma 1. We want this. It's not possible. It doesn't happen actually. So this is how you can calculate it. FP is false positive is 1 when it is a wrong type. F1 is 1 when organization is missed. It was true, but we couldn't find it. Precision is 0.5. Recall is 0.5. Then F1 is also 0.5 because 2 PR divided by P plus R. 2 into 1, 2 into 0.5 into 0.5 divided by 1. So it's 0.5. Now, there are some data sets and they have some tasks to be done and in the different languages. How many tokens are there? How many tags are there? In the pantry bank, we have part of speech plus parse tree. is possible with this data set. It's very, it is also known as a gold data set, gold standard. It is in English. We have 1 million tokens and 45 pantry bank tags. Cornell, it is for NER, and it is in English and other language, I think it's DE. 300K tokens, and we have person, organization, location, and some miscellaneous things. And Ontonauts, WNUT, MUC, UD3 Bank, AC 2005, BC 5CDR. These are the names of this, and the purpose is different. Look at this BioNR. BioNR means biological named entity declaration. So what are the different part of speech tagging applications? Parsing and syntax tree, grammar checking, machine translation, morphological analysis, self-checking context, text-to-speech stress patterns, lemmatization, and stemming. That is possible with, these are the use cases of part of speech tagging applications. While NER applications are search and entity linking, new summarization means if we ask some questions, based on the questions, we can summarize our news. Clinical NLP, financial analysis, customer support routing, chatbot and virtual assistants, scientific literature mining. On the basis of the topics, we can scientifically find the, we can use the knowledge using the some keywords and reach to the conclusion. So error analysis, common failure modes like in and out. Model predicts New York, but gold is New York City. Although they are same, but they are considered different. Type errors predicts BORG for Washington instead of BGPE or PER, geographically based entity. Out of vocabulary errors, unseen words in the test case, if they are not trained yet, so they will be not showing up the correct word. Long entity spans, international business machine corporation, models may truncate. Ambiguous context, Apple released earnings. So Apple is a product or a organization. Apple is the name of the product as well, and Apple is the name of the company, and Apple is the name of the fruit. So it is true that it is not a fruit. Apple released earnings. Fruit cannot release it. It may be organization and product. So here the answer is organization. Annotation inconsistency. Even human annotators disagree 5 to 10% the time. Annotation means annotators who are the experts. If I say 5 experts are there and or only 2 experts are there, they have the disagreement about a word or a token, then may lead to inaccurate results. Best practice, examine confusion matrix per entity type, oversample rare type. What we mean by confusion matrix? Confusion matrix is this. It is true positive, false positive, false negative, and true negatives. And how do we define it? It is actual, and it is predicted. So actually it is true and we predicted positive. It is true positive. Actually it is false, but we say it's a positive. Actually it is actually it is true, but we say it is negative. And negatives are actually these are negative and we say it's a negative. So these are true negatives. So this is confusion matrix. So what is the trade-off? How do we improve the accuracy? So for every class, For every type, we say, for example, if I say NER is a name of the person. For every type, we find this confusion matrix. So we are worrying about FP and FN. It should be less, while TP and TN, these are good ones. So we need to increase them and we need to decrease these two fellows, FP and FN. Right? For every entity, if we can do it, then we can reach to some conclusion. This is creating issue, this is creating issue. And within this, within the issue, what is the say name of the person, which name is creating the issue, right? And oversample rare types, it means because these tags are millions of millions. So we need to oversample, means we need to draw, we need to pick the things, the entities, those are rarely appearing, so that they are not missed out for testing. I hope it's clear. So this is all about this NER. So LLM based NER is there, GPT-4, Llama and Zero, few short settings. What do you mean by zero and few short setting? That nothing is given, no training, then still the Y, if X is not, X and Y sample is not given, no training is given, still we can find the Y for the X, then that is zero. And few short, some of the examples are given. This is X, this is Y, this is X, this is Y. Now you find the Y for the new X, that is few short. And no label data needed. We don't need the training one. Then span based NER predict start and end of the span. That is very much important. Like we have Barack Obama, we have United States of America. Cross-lingual transfer, when we convert one language to another, then fine tune on English because it has a big data on MBERT and Indic BERT. We have Indian languages के लिए BERT है, that is known as the Indi BERT, Excel, MR. These are the data set. So here the transfer is possible. Domain adaptation, continue pre-training BERT on domain text, BioBERT, legal BERT, fine BERT. And weak supervision, use distance supervision, link text to KB to create noisy training data automatically. So supervision, as you understand, that there's some training and supervisors there, that is in terms of Y. But to create noisy training data automatically, we can have a distance supervision. Structured prediction with PLM, T5 is the text to transfer model, something TT, all T's are there. These are prominent nowadays. And GPT generative pre-transfer model, generate entity spans as text, no IOB scheme needed. Now, the last one is the interpretability, attention maps, probing classifiers, understanding what models learn about syntax. So basically it's all about the new things, those are coming up, and the scope for the research. So those attendees who need some ideas from this slide, they can reach it or just go into the detail. The references are given at the end. Now is the time for the last questions. What we mean by precision is the correct prediction out of total prediction, correct positive predictions out of predicted positives. What is the formula for precision? TP divided by TP plus FP. TP is a true positive, FP is a false positive. So total predicted out of how many are true positives. Correct predictions out of total actual values. If we say total predictions, fraction of predictions out of many, then it is accuracy. But we are only asking for TP. Precision. Precision is TP divided by TP plus FP. So it's a correct positive prediction, that is TP. TP is the correct positive. Out of total prediction कितना था? TP plus FP. Out of this. So this is the answer. Yes, correct. Similarly, recall. Recall is TP divided by TP plus FN. Recall. What is the answer? B. True. Yes. Because this is correct. Positive prediction is nothing but TP. And out of actual positives means TP plus FN. FN, those are missed out. They were positive. But we said it is negative. Actually, they are positive. So that is TP plus FN is the actual positives. This is the answer. So what is the takeaway from this lecture? So we have sequence modeling. We have seen labels depend on each other. Model the full sequence, not taken in isolation. Part of speech tagging, grammatical categories per token. We have seen band, tree, band, 45 tags, or universal part of speech tags, 17 tags. NER, detect and classify named entry spans using IOB BIOS labeling scheme. These are the names of schemes. Classical models, HMM, that is kind of a generative. MEMM, that is discriminative. And then CRF is discriminative, global normalization. Evaluation is token accuracy for part of speech, span level F1 for NER, use SQL in Python is the name of the library. SCQ, sequence EVAL, evaluation के लिए. Sequence evaluation, name of the model, name of the library, sorry, in Python. You may use it. And libraries, those are available and prominently used for this purpose. SPACY, NLTK, Hugging Face transformers, and they are readily available and giving the good results. So this is all about our third topic, sequence modeling. Now, it's the time for the questions. If you have questions, please write in chat. No questions? So again, it's should we take a break for 10 minutes or continue with the hands-on? How do you want? So now whatever has been done in theory will be explained in tutorial hands-on with the coding. I urge everyone to please take your laptop, start working with us. So whatever has been done today in theory will be done in practical hands-on. And of course, we'll be providing you the notebooks. Don't worry about it. So it's okay to continue? Yes.